Hello class, this is video number 4 for the counter sequence design. Once again, the exam will not give you flip-flops. You'll have to memorize how to draw flip-flops, which is why I'm going step by step, so you can calculate how much time it would take to do the counter sequence design. And this is a major part of the assessment for the final exam. It's worth quite a few points, and you will know this if you look at the mock exam that was given to you and the sample problem that was given to you for the counter sequence design. Now if you notice, when I actually did the drawing here, I'm using Q0 first and Q1 second, because in flip-flop design or in counter design, normally the zeros come first and the most significant bit come last. However, when I did my design, I did my 1 0, because generally when we count numbers, we put the most significant bit on the left and the least significant bit on the right. Now these are two synchronous counters, which means that the clock signal will be connected together so that both flip-flops will change together from the clock. This is usually a symbol for a clock, and it can be active high or active low. I'll use active high. You have to look at your problem to find out what to use. Now if we look at J1 and K1, it says that both of these will be a constant 1. So to show that in my drawing, I will write the word high, and then I will connect a wire to both J1, jump across the clock, and connect it to K1 with a little dot to show that they are both connected. Now there are many ways to show. I could have put a 1 here and a 1 here, but you just have to be clear that you indicate on the exam what the status of your J and K. Alright, so here's Q1 and here's Q0. And the opposite, of course, is below. Every flip-flop has an opposite output because knots are part of the logic. You can have active high or active low. Now J0 and K0 says that you have to connect it to Q1, which is over here. So I'll change the color to make it clear that I'm going to connect J0 and K0 together, and then I will put a wire, and if you think about it, the output is feeding the input. This concept is called feedback. Have you learned about feedback in other courses, especially in the amplifier course? Feedback is necessary in order to stabilize an amplifier. Alright, so these are your output points of this counter sequence design. We have finished making the final connections for this simple state. Normally what we will do is we will initialize these flip-flops using the preset or the clear, and then we will proceed to clock it, and it will operate through this sequence that is given. One more check to make sure everything's okay. J1 and K1 is connected to high, which represents a 1. And K0 and J0 is connected to Q1, which is fed back to the first flip-flop. Thank you.